Hey guys, I recorded this once. It got a little long, so I'm splitting it into two videos. Okay. Um, this is 6.5.B. We're graphing linear inequalities, and our objective is to graph linear inequalities. Second video will be continuing that as well as creating linear inequalities from a graph. So just flipping it around. So the graph of a linear inequality is called a half plane. All right. The graph of a linear equation is a line. So the graph of a linear inequality is a combination of things, of a line and shading. And that's why it's called a half plane. A plane is a geometric term you'll learn more about next year, but it's pretty much a two-dimensional surface that goes on forever. And this is half of that. Now, not necessarily if you cut it in half exactly, but that's just what it's called. And then all the points in that area that we shade, those will be solutions, answers that will make the linear inequality true. So here is an example of two different linear inequalities. There's going to be a little bit of information here. You may want to circle back to it a little bit later. So notice this first one, it's pointing to that red line. It is a solid line. So if your inequality is less than or equal to, or greater than or equal to, key is or equal to's for this, you make a solid line. Everything on that line and in the shaded region are solutions because it's or equal to, it includes that. The one down here, that's a dashed line. You got to look a little closer. It's a dashed line. When the inequality is y is less than or y is greater than, notice no or equal to, you draw a dashed line. And any points that are on that dashed line, those are not solutions because those are exactly equal to. So if it's a dashed line, it can only be the points that are in the shaded region. Whereas as if it were the solid line, it could be on the line and in the shaded region. Now we got to look, do we shade? Where do we get the color? I want to know, where do I get the shade? So if you have an inequality greater than or equal to, you shade above because it's saying y is greater than this information. The y-axis goes up and down. So if y is going to be greater, you find a point on that line or dashed line and you go above it, up, and you shade that entire area of your graph. And that will be all the points. So all the points in green here, up here, would be a solution to that inequality. And then if it's less than or equal to, y is less than that, y is lower than that, you shade below your line. So this is the process on how to do this, okay? Step one, we need to do what we learned last section, and that is solve the inequality for y. A lot of times it'll already be there, but you need to isolate your y. Be careful of flipping the signs if you're dealing with dividing by or multiplying by negatives. Step two, you're graphing your boundary line. Your boundary line is AKA slope-intercept form. Your y-intercept and then your slope. Then you have to be careful. You have to use a solid line if it is or equal to, less than or greater than or equal to. You're going to use a dashed line if it's only the inequality sign with no or equal to, greater than or less than or greater than. All right. Then third is you have to shade. You're going to shade the half plane above the line if it's greater than or equal to or greater than. You're going to shade below the line if it is less than or equal to. So let's real quick take a look here. Will these be solid or dashed? So look at number one. Y is greater than 5x minus 3, solid or dashed. And number two, same thing. Even though it's not in slope-intercept form, just look at the inequality and tell me solid or dashed. Number one is dashed because it's no or equal to. And number two is a solid line because it could be equal to that. Okay, now let's get into actually going through the process of graphing this. Put myself down here now. So now I have y is less than or equal to 2x minus 3. Step one, we got to put it in slope-intercept form, aka solve for y. Like I said, it's already done for us. So we need to identify the two things. What is the y-intercept and what is the slope? Y-intercept is -3. Slope is +2. So what I'm going to do now is I'm going to start plotting points. I'm not going to connect anything yet. I'm just going to plot my y-intercept as -3, 1, 2, 3. My slope is 2, meaning from there I go up 2 to the right 1, up 2 to the right 1, and I can make a couple more. And now, in the past, we just drew our line directly on there. We drew our line. But now I have to go back and look at it's all about this sign. All right. It's less than or equal to. So that means I'm going to use a solid line. I'm going to get my solid line tool and extend my line all the way through my graph. So that means any spot on this line is a solution, but it also is y can be less than that. Since y can be less than that, I'm going to look at any point on my line and I'm going to go less than that, lower than that, below that. So everywhere down here, it's a little bit quicker if I get my highlighter. Everywhere below my line, I would need to shade. And that is saying any point down here, this ordered pair, this ordered pair, this ordered pair, all these ordered pairs would be solutions to this inequality. If I were to plug that x and that y in here, it would be a true inequality. Whereas if I were to put one of these ordered pairs, if I get really close, that would not be true. Meaning when you plug the x and the y in, it won't be a true statement. What about this one here? Graph this one. Oh, this one we got a little more work for. What do you get when you solve this one for y? Hopefully you got y is greater than 4x plus 2. You had to flip the sign because we're dividing by -1 to end this one. And to graph it, I'm not going to cheat, but I'm going to use Desmos to show you what Desmos looks like. It draws a dashed line because it's only greater than. Y-intercept is 2, slope is 4, and then it shades above the line, not left versus right, up versus down, because we're dealing with starting with y. We're starting with y, so y is greater than it above the line. Okay? And that's it for video 1. Check out video 2 now.